law of cosines. Now this will take care of the other two triangles that we haven't had yet, where if you have an angle side angle, which is actually not that picture right there. It's unfortunate. Let's get rid of that. And yay. All right. So if we're talking about angle side angle, you've got two angles that both touch the side, right? Just like both of these A's both touch this S here, right? So you have to have the side that's between two angles. Or if you had all three sides, you wouldn't be able to do the law of sines for that because you just don't have the right matchups. Right? So to get around that, we have the law of cosines. So you're really not using the law of cosines that much. Usually law of sines is what you're going at. But if it doesn't work, you've got this one. Right? So this is the law of cosines. Now there really are three formulas in your book for this one. But I think the A's, B's, and C's are all arbitrary anyway. So I tried to pick the one that was going to be the easiest for you to remember. Right? I think that this one is the easiest for you to remember because if you take this part off over here, what is it? Well, it's something else. It's the Pythagorean theorem. All right, so you have c squared equals a squared plus b squared. Right, then it's minus, and then it goes in alphabetical order. So 2ab cosine of c. Right, and that I'm hoping that that's going to be the easiest one. The other one, when you start mixing up the letters, there's no real easy way to remember it. So you've got the Pythagorean theorem in there, minus 2ab cosine of c.
Cosine C.
Okay, that's what it takes for you to remember it. Great. All right. So if we look at this triangle here, and I just want to start labeling some things. So one of my sides is going to be 2. One of my sides is going to be 3. Right? So since little a is across from big A, that's going to go there. And little b is going to be across from big B. That means that this one has to be C. So this is going to be 60 degrees. And this will be little c. So we need to find those other two angles, which I can't just look at and get. And I need that other side.
Little c, the square root of 13.
No. How do you get that? Oh, because it's not a right triangle, so that's out. Yep. So we need another alternative. So that's what's kind of nice about the law of sines and law of cosines is they work on any triangle, not just right triangles. All right, so if I plug this thing in into the formula, so we know that the first part of it is the Pythagorean theorem. So c squared equals a squared. Okay, what are we going to use for a here? 2. So 2 squared plus b squared, 3 squared, minus 2a times b, cosine of angle c. All right. So c squared is going to equal 4 plus 9 minus 4 times 3 is going to be 12, cosine of 60 degrees, whatever that is. All right, so c squared equals, let's see, this is going to get me 13 minus 12 cosine of 60 degrees. All right, finally, I'm kind of at a point where I have to type things into the calculator now in order to get my decimal. So I'm going to get the cosine of 60 degrees is a half times 12. So I'm going to have 13 minus that answer. Yeah, so that's why I went 13 minus whatever I got for this. Okay, so I get c squared equals 7. So square root of both sides. So c is going to come out to be the square root of 7. Okay, so now how am I going to get the angles?
Those laws that you just showed us.
Yeah, do I have to use the law of cosines again, or can I use something else that's easier?
Side.
What?
Law of sines.
Yep, law of sines is going to be a heck of a lot easier. So let's go with angle B. So sine of B over 3 is going to equal what?
Sine of A. Sine of 60 over.
Sine of 60. I could use the A if I actually had a number there, but I don't have that, so I don't want two variables in the same problem. So I'm going to go with this one. All right, so when I cross multiply, I'm going to get square root of 7 sine of B equals 3. marker's a little off. Sine of 60 degrees. All right, divide both sides by square root of 7. So I'm going to get the sine of b equals 3 sine of 60 over the square root of 7. Then what?
Do it.
How do you get b by itself?
You inverse sine both sides.
Okay, so I'm going to have to inverse sine both sides. So b is going to come out to be approximately whatever that turns out to be. So I'm going to go sine of 60 times 3 divided by the square root of 7. Right, and then I'm going to take that solution and I'm going to inverse sine it. And I get 79.1 degrees. All right, so if this angle is 79.1 degrees,
That's the other one.
okay, then what?
Subtract it by 180.
So I'm going to get 40.9 degrees. And now that triangle is solved.
I'm good. I don't get 3 sides.
Triangle. You're killing me. All right. How about side, side, side? So it doesn't really matter what I pick for my which points are which. Oh, actually it kind of does. Take that back. Right? So we want the longest one to be the one that looks longest. So this will be 6. That'll make this one 4 and this one 3. That's going to decide where my vertices go. So little a is across from big A. My 3, which was B, is going to be across from big B. And that means that this one will be across from big C. Right. So, no, I didn't guess at all well. All right, so now I have to come up with something because I have no angles. So I'm going to have to find one. So if we do the law of cosines, right? So I've got c squared. What's that? Hmm? It'll be a variable. Okay. So.
Wait, are you doing the law of cosine?
Uh-huh.
Yeah, so 36.
Okay, so c squared, we're going to go, I'm going to write it this way first, and then we'll switch it. Okay, equals a squared
4 squared
plus
6 squared.
3 squared.
Whatever.
Oop, but you got me thinking 6. 2 minus 2a 3 cosine of c.
Boom, got that down.
Okay, so I've got 36 equals 16 plus 9 minus, well, that's going to be a 2 times a 4, that's 8 times 3, so minus 24 cosine of c. So that's 36 equals 25 minus 24 cosine of c. Now what?
Now,
I have to start getting this c by itself. Subtract 25. So now I've got 11 equals negative 24 cosine of c.
can you divide by 24?
Yep. Divide by a negative 24.
Equals cosine.
Okay, so then I want to inverse cosine both sides. So I'm going to get c is going to be approximately whatever I get here.
So in that case, you just do 11 divided by negative 24, and then inverse cosine and answer.
Yep.
A equals pert.
Yeah, that's for another class. Actually, that's for your class just later. So I've got inverse cosine of that answer.
God bless you, Chris. Thank you. Let the records know I blessed you.
Okay, so I got 117.3 degrees. So this is 117.3. Can it be bigger than 90?
Yes.
Yeah. As long as it's not bigger than 180, we don't have a problem. Yep, so that should make sense. It looks like it could be obtuse. All right, now how am I going to find the other angles? Yep, so now we switch to one that we like a little bit better.
So sine of 117.3 over 6 equals sine of 4, no, sine of A
Mm-hmm.
over 4.
Okay. So we cross multiply. So I'm going to get 4 sine of 117.3 equals 6 sine of A all over 6. So I'm going to get 2 sine of 117.3 over 3. I just simplified here.
Why is that all over 6?
Okay, equals sine of A. Then we're going to inverse sine both sides. What's that?
Why is it all over 6?
I divided both sides by 6.
I didn't see
And then I simplified here, so that's why I got 2/3.
I just missed it.
You don't really have to do that. The calculator will figure it out for you. But
No, I just didn't see. I didn't realize you were doing a step. I thought you were rewriting it. I was like, why are you writing it over 6?
I got you.
I didn't realize that was a step yet. Well, I did. Shut up.
All right, so I got my sine of 117.3 times 2 divided by 3, and then I need to inverse sine that solution. And A is going to come out to be 36.3 degrees. So this one. All right, so if I add that to the 117.3 and then subtract from 180, I'm going to get 26.4 degrees. And now that triangle is solved. All right. All right. Well, in an attempt to fly from Chicago to Louisville, a distance of 330 miles, a pilot inadvertently took a course that was 10% in error, as indicated in the figure. So the first thing we want to do is, if the aircraft maintains an average speed of 220 miles per hour, and if the error in the direction was discovered after 15 minutes, through what angle does the pilot need to turn and head towards Louisville?
Question.
Yes.
How can you be 10% wrong on something? It's either he's right or he's wrong.
No, he's 10 degrees off.
He's 10 degrees here.
Correct. 10 degrees off. So he wanted to go this way, but he was 10 degrees going this way. It's possible. Oh, well, he never should have taken. Well, I suppose that's probably the pilot's fault.
And then as soon as you go 100 feet off the course or something, some random number, they're supposed to shoot you down. So this is a false problem.
I'm sure they would have given him some warning. All right, but there is a problem with this problem. Does anybody see it?
Well, we need some more information.
No, you're good. You got enough info.
The jet is not the same size as the city.
Well, those are just mascots. So there is a problem, though. What's wrong with this?
So do we have to take the speed and then multiply by the miles per hour to find out how far the bottom length is?
Yep.
So what's the problem?
That's not the problem, but I do need that. So what is, how far will they have gone in 15 minutes?
Well, whatever 15 times that number is.
No. That would be, they would have gone really far if you multiply 220 by 15.
Oh, you
That
divide
would be
by
enormous.
1/4.
Correct. You would multiply by 1/4 or divide by 4.
Yeah.
Okay, so what is 220 divided by 4? Mm-hmm.
Wow, I knew that.
So this is 55 miles.
Okay. Well.
Okay, so I've got that.
So it might not just take off.
Well, my guess is that they took off, and the runway was 10 degrees off of where they really want to go, and the guys just never turned.
They're on Facebook.
All right, now if I want this angle in here, what trig function should I use?
Shucks.
Which law am I going to want to use here? You guys never did figure out the problem with this problem. All right, the way that I have it oriented, Louisville is not northeast of Chicago.
That's what I was trying to figure out.
It's actually southeast of Chicago. So
Yeah, but it's a problem.
yeah, I mean, we really just need a picture to like help
Yeah, but
us.
who's to say it's north?
Yeah, who's
No,
the-
the earth is
Somebody
who's
made
the-
that
what's
up.
north and what's
Yeah,
south?
what's
I
south?
don't know, some old dead guy.
Yeah. So I don't
So
believe
okay,
the
thanks.
world's flat.
Thanks for
anyway.
having faith in me.
I've never fallen off.
All right, so if I let that angle be x, all right, do I have enough here that I can use the one that you guys like? Law of sines?
No, you have to use the angle side.
Well, look, if I go sine of this angle across from this one, right?
Yeah, but then you have nothing else to compare.
That's right, so I'm out. So I'm going to have to use the law of cosines.
I thought the law of what you call it?
Mhm.
Oh, it's on information.
Mm-hmm. So I'm going to have to use the law of cosines, which means that maybe I'm not going to be using this angle right now, but I'm going to have to use it later. All right, well, if I use the law of cosines, then I only have this one angle to use. So that's going to have to be my cosine of C. Right? Well, this one, this big C angle is supposed to be across from the one that's going all the way over here to the left. So what should I be using for over here? Yeah, I don't have that one, so that's what I'm looking for right now. Right? Do I have an A?
Well, you could either use well, how do you know which one to use for A?
Doesn't matter. It's arbitrary.
We're gonna use it.
Okay, so 55 squared plus B squared, that's my 330 squared, minus 2 times 55 times the 330
It's 330
times that. All right, so now I can figure out what my C squared is going to be. So we're going to get some pretty big numbers here. 55 squared. All right, so 3,025 plus 330 squared, 108900, minus, let's see, that's going to get me 2 times 330 times 55 is 36300, cosine of 10 degrees. All right, so 3025 plus 108900, and I'm going to get that C squared is 30, no, we got that 111925 minus 36,300, cosine of 10 degrees, and now I can start just typing things in to get it. So I'm going to have the cosine of 10 times 36300, and then I want to go 11925 minus that value. 11925 minus that value. And we're going to get C squared is approximately 76176.5. Take the square root of it. And C is going to come out to be 276.0008. It might as well be a 276. Right? Okay, so this is 276 miles. Now, how am I going to find that angle X?
Easy limits.
Using what
Sine
formula?
of 10 over 276
Yep. Equals?
equals the sine of whatever we don't X, sure.
Okay.
Over 55.
Nope.
What?
330, because that's the one
yeah,
that's
yeah.
across from it. Okay. All right, so when I cross multiply, I'm going to get 330 sine of 10 degrees equals 276 times sine of x. Divide both sides by 276. All right, so now I've got 330 sine of 10 degrees over 276 equals sine of x. What do I do to both sides?
Inverse sine.
Okay. And then I can come up with the decimal for that. All right, so I'm going to have sine of 10 times 330 divided by 276. And then I need to take the inverse sine of that answer. And I'm going to get 11.98, which is going to round to approximately 12 degrees, 12.0 degrees. All right, well, that's what
Wasn't I gonna mess up?
this was going to be. Now, does that make sense?
No,
Why not?
because then the other one would be like 160 degrees.
Right, and you're not going to take a plane and you're going to just turn it around 168 degrees so that you can go this way. Clearly, that's not right. Why did this work out this way?
Oh, the little. Hey, Mr. Morse. It's the one flat-bead one.
Correct. It's the ambiguous case, right? But, and that's why I picked this one. It's an easy fix though, because where does the 12 really go?
What
the 12 degrees that we found there. We can use it.
It should
It's
be
just
on
not the
top.
inside. It's this one. Okay, this is the 168 degree turn. So, what degrees did they actually have to turn in order to change?
168.
No. They're going this way. How many degrees do they need to get back on track? The 12. Okay, because it's this outside one. We were always looking for the inside one because it was inside the triangle. That's not really the one we wanted. We wanted the one on the outside because that's the correction that the plane is going to make. Okay?
Okay.
Okay, so be careful and make sure that when you draw your picture and you start labeling things, make sure that the numbers make sense when you plug them back in. Clearly, this obtuse angle is not going to be at 12 degrees.
Is 12% at the top then too?
The 12 degrees, no. This would actually be much smaller.
Okay.
168 plus 10, that's 178. This is 2. These guys really weren't that far off. Okay, which is the next question. Oh, I guess not. I thought I had a part A and a B for that. Oh, I did. I just did my work down here for B. So part B, it says, what new average speed should the pilot maintain so that the total time of trip is still 90 minutes? Okay, so how am I going to figure that one out? How far did they actually have to travel?
Well, 55 miles.
Well, the 55 miles already made them, it took them
So
15
then we
minutes.
subtract the 15 minutes from the 90.
Okay, so I really only want to go 75 minutes, and how long do I have to go for that?
276.
Okay, so that's what we need to figure out.
So can't you just divide it?
So I'm going to have 276
Divide by
miles divided by,
65.
close, 75 minutes, but we don't do miles per minute, not in an airplane.
So then change that to hours.
Okay, so I'm going to have to multiply this one by 60
Which
minutes in 1
1.25.
hour so that these cancel.
You don't do miles per
Wait,
hour
no.
on an airplane either.
Well, that's probably accurate.
Yeah, you do.
60 times 276 divided by 75. So we're going to get 220.8 miles per hour. How much did they actually have to speed up? 0.8 mile per hour. So they really weren't that far off. Right, so as long as they didn't let it go too far, they were going to be okay. 220.8 miles per hour. We were already going 220.
So
So
191.87 knots.
there you go. That's like hardly a click on the changing speeds.
Yeah, because it's a click. Yeah, jeez.
Mr. Boysick would be ashamed of me right now.
No, it's actually a throttle quadrant.
Does he know what it's called?
No.
So that's what we're calling it. The changing speeds button. Okay. Eh.
Does your car have a button that you change your speed?
No, I have a pedal.
So why would
Does an airplane have a pedal?
It has two pedals.
Technically,
Yeah.
pedals.
Really? They're for rudders. It's not like a gas and a brake.
Oh, how do you speed up?
You have a throttle that goes up. You've never seen that in movies when they're being all dramatic and they're like, "Ah,
No.
there's a car chasing us."
In an airplane?
Yeah, and then reverse thrusters is all the way back.
Okay.
Then right next to it is your flaps, with on a 747 it goes back and forth. But on a normal airplane, it's a little switchy.
Okay. Law of cosines, pretty easy.
I don't get it.
Okay. So usually when you're doing these problems, you're going to use the law of cosines, so then you can use the law of sines. Right, so it's finding a piece of information so that you can use the one that you guys really like. All right. There's your homework. Not that bad. 43 through 53 odd, but I also want you to do 44.